I'm not.
So you're drawing a sketch again. You have your tripod with your wire mesh, your Erlenmeyer flask with water.
Is the water boiling?
Yes. So next to this setup is a bucket of ice water. Next to the setup is a bucket of ice water. There is. The Bunsen burner is on and it's heating the water. Right now the water is actually burning.
Just listen.
Just listen. Okay. So for the balloon and flask lab, my question to you right now is, the water inside is being heated. What is happening to the molecules of the water? Okay, so they start to turn into what?
Gas.
A gas, steam. Okay, what are the molecules doing? They're turning into steam, right?
Moving faster.
Moving faster, hitting each other harder. Great. What if I were to put this glass top on top? I'm not going to secure it down. I'm just going to place it on top. Joe P. Okay, so it's already steaming inside and it's bubbling, right? Okay, well let's test that. Is that the only thing that'll happen, you think?
No.
Anthony?
I think maybe it'll like push off.
You think it'll push it off? Let's test it
Yeah,
out.
it's gonna blow.
Are you ready?
She's ready to catch it,
It's gonna blow off.
so it's gonna break it.
Listen. Listen. Do you hear it?
No. Wait, what is it?
Do you hear that? So it's glass on glass. The glass is jumping because the air molecules, or not the air molecules, but the steam molecules that are now gas, want to pop it off. Okay, and it actually did last class.
Is that
And
why
it
everybody
broke.
screamed?
It broke.
That was a couple classes ago. Okay, now what I want, so you clearly know that the molecules are moving inside the flask. They're bumping around. They're trying to get out. I want you to make a hypothesis. I'm going to put the balloon on top of the neck of the flask, and then we are going to take the hot flask and put it into the cold ice bath. Obviously, you're not going to do this at home with your normal glassware, because it will do what? Break. But with this, the Pyrex, we should be good to go. So what do you think is going to happen when I put the balloon on top and then put the Erlenmeyer flask in the ice? Tate,
Like suck in.
what's going to suck in?
Blow.
Okay, you think the balloon will suck in. Jonathan,
It's gonna pop off.
you think the balloon will pop off when? When it's on, but above the heat or in the cold? Okay, above the heat. All right, I'm sorry, what's your name? Patrick.
It's gonna blow up the balloon.
You think the balloon will blow up when?
Once it's like heated and you put it on.
Once it's heated, and what's going to happen when it goes into the ice bath?
It's gonna
It's
go.
gonna deflate.
It'll deflate. All right, so we have a couple different things that you think will happen. Go for it. So we're going to turn the fire off.
That is safety.
Whoa.
Up.
Cannot see.
Oh boy.
Things good? All right.
Take your time.
So right now, with the balloon, it did inflate. And now watch as we put it in the ice bath. What happened to the balloon?
It
Sucked
deflated.
in.
It deflated.
Oh.
Oh.
You said a couple words.
I said.
Okay, but you keep saying that it's getting sucked in.
Wait, what?
That's not the right. That's technically that's not what's happening. It did. You did get it right in the sense that you knew it was going to go inside the flask. But is it being sucked in? Why is it going inside? Shh, Matt.
It's getting colder. It doesn't take up as much space.
Okay, the molecules. What does? Which molecules?
Air
The steam molecules. Okay, pretty much push a lot of the air out. But the steam molecules do not take up a lot of space. They do what? They condense. They condense. And what else changes inside?
Heat.
What else changes?
The pressure.
The pressure. So right now the pressure inside the flask is, it's what?
Lower.
It's lower than the pressure where?
Outside.
Outside. So why is the balloon going inside? Mia, say it louder.
It's getting pushed in by the pressure outside.
Perfect. Since the pressure outside the flask is greater, it's pushing the balloon inside. So it's not getting sucked in. It's getting pushed in because the pressure outside is greater. But you knew exactly what was going to happen. It was going to go inside. So good job. Does everyone understand this?
So our conclusion
Very
is
nice.
a lot of things happen. Can you describe how like why?
Sure.